So we're asked to consider the region bounded by the first quadrant, y equals ax squared, and the line y equals c, where a and c are positive constants. We're going to revolve this region around the line x equals -2, which will make a solid. So we want to set up and evaluate the integral that represents the volume. So first off, let's go ahead and draw our curve. And ax squared is just our quadratic here. And then we have some line y equals c. And here is our solid because it's also in the first quadrant. Now we're going to revolve around the line x equals -2. So our curve is getting revolved around this way. So we see that we're going to have an open center. So here's kind of a mirror image. We're going to have an open center there. And so to calculate the volume, we're going to have pi, and we're going to have a big radius squared minus a little radius squared. And because we're going around a vertical axis, it's going to be dy in terms of a washer method. So we have to identify our big radius, little radius, and also our limits. Now our big radius is going to go from the axis of rotation out to our curve. And so that needs to be our curve, which as of right now is y equals ax squared, but we need it solved for y. So it's x equals square root of y over a. That's our big R. Our little r, or not quite our big R, excuse me. Our big R that's the distance from here to the y-axis, and then we had to add another 2 on there. So our big R is square root of y plus a plus 2. So we're starting to put this thing together. So square root of y over a plus 2, that quantity squared, that's our big R. Our little r is actually pretty simple because notice no matter where I write it, it's always the same length. It's just 2. So -2 squared, but we don't want to forget that guy. Okay, our limits, last thing, y is going to go from 0 up to this line, so up to c. So 0 to c. Now we are ready to multiply things out and simplify. This has to be FOILed out. Square root of a times square root of a is just y over a. Then we're going to have square root of a times 2 plus square root of a times 2. So we're going to have a plus 4 square root of y over a. And then 2 times 2, so plus 4, and 2 squared is also 4. Those are going to be nice and cancel out for us. I'm going to do one more step of rewriting before I go ahead and evaluate. And don't forget my limits, 0 to c. I'm going to write this as 1 over a times y. And this one I'm going to write as 4 over square root of a times y to the 1/2. So I'm taking this because it's a constant, and I'm just going to write it here. So I can just leave that as a constant. Those cancel, so there's my dy. Now we'll do our antiderivative, and then we'll plug our limits in and finish up. So pi. This is going to be 1 over a times y squared over 2. And this is going to be 4 over square root of a. This is going to be 2/3 y to the 3/2. And this is from 0 to c. So, now what we have to do is plug in our limits and finish off. But before I do, I'm going to go ahead and simplify as much as possible. So pi, I'm going to write this as y squared over a. And this one here, plus 8 over 3 square root of a. And if you want, you can write it as y to the 3/2, or if you wanted to do square root of y cubed, either of those are fine, from 0 to c. Now what we can see is if we plug 0 in, the whole thing is going to 0 out. So we really only need to plug c in to finish. So pi times c squared over a plus 8 over 3 square root of a times the square root of c cubed. And there's our final answer.